In this video, we'll begin our discussion of energy transfer during chemical reactions. Let's take a look at the chemical reaction between nitrogen gas and oxygen gas to make nitric oxide. Before the reaction takes place, we only have nitrogen and oxygen in our container. Notice that the temperature in the container is relatively high. Let's now allow this reaction to proceed. We see that we formed nitric oxide, which is what we expected. But something else has also happened. The temperature in the container has decreased. Recall that we talked about the relationship between velocity, energy, and temperature in a previous video. So why does the temperature decrease? Temperature and speed are directly related. So a decrease in temperature tells us that the molecules in the container have slowed down. These molecules have slowed down because they've lost energy. Where would you expect this lost energy to go? The energy lost by all of the molecules in the container was used to fuel the chemical reaction. You see, this reaction is endothermic. It requires energy to be provided in order to take place. In all reactions, some bonds are being broken, which costs energy, and other bonds are being made, which releases energy. But overall, for this endothermic chemical reaction, we must supply more energy to make the reaction take place than is released during the reaction. So delta E of the reaction is greater than 0. That means that the endothermic reaction absorbs energy from the things around it to take place. The heat taken in, or gained, by the reaction in order for the reaction to take place is called the heat of the system. This energy is taken from all of the molecules nearby when the reaction takes place. In this case, all of the molecules in the container, both the reactants and the products, spectators like water, the container material, and the thermometer all lose energy. They are called the surroundings. The surroundings lose energy when the system takes in or gains energy. How much energy is gained by the system? Energy is always conserved. This means that the amount of energy gained by the system is the same amount of energy that is lost by the surroundings. When the system gains energy, that fuels the reaction, making it happen. The surroundings, since they've lost energy, get colder. Reactions that give off energy as they take place are called exothermic reactions. The system, the bonds breaking and forming, releases energy to the molecules around it, the surroundings. That means that the surroundings gain energy and get warmer. One important caution. Anytime we measure temperature, it is always the temperature of the surroundings. After all, the system is just the bonds breaking and being made, and you can't measure the temperature of a bond.